Morning everyone. Today we will be discussing database security, specifically focusing on what databases are, the common protocol they use, the vulnerabilities, and most importantly, how to harden them on both Windows and Linux systems. So here is the introduction. Databases are central to various applications storing crucial data like customer details, financial records, and operational information. Because they handle sensitive information, they are a prime target for cyber attacks. In this session, we will explore how databases work, the threats they face, and methods to secure them, ensuring the confidentiality, integrity, and availability of your data. So, what is a database? A database is an electronic system that organizes and stores data, making it easily accessible and manageable. There are different types: relational databases like MySQL and NoSQL databases like MongoDB, each catering to various data needs. They are varied across sectors, from banking to healthcare, to manage large volumes of structured and unstructured data. These are the common database protocols. Databases use different protocols for communication and data management. SQL, also known as Structured Query Language, is prevalent in relational databases, allowing data retrieval and manipulation. NoSQL databases, like MongoDB, use protocols tailored for unstructured data. Middleware protocols like ODBC and ZDBC facilitate facilitates secure communication between applications and databases, often using SSL/TLS for encryption. So, how does databases work? Databases store data in tables for relational databases or collection for NoSQL. Users query these databases using SQL commands or API to retrieve, insert, update, or delete data. Transactions are crucial here, grouping multiple operations to maintain data integrity, ensuring that either all operations are succeed or none at all. These are the database vulnerabilities. Despite the robustness, databases are prone to several vulnerabilities. SQL injection is a common attack where malicious code is injected to gain unauthorized access to data. Many databases operate over unencrypted connections, exposing data to intercepting weak authentications like using simple password or default setting can further increase risks. Misconfigurations such as using default ports often make databases more accessible to attackers. Here is how to harden databases on Windows. Securing databases on Windows involves several steps. Firstly, enable SSL/TLS for encrypted connection, ensuring that data in transit is protected. Integrating with Active Directory allows robust authentication using domain policies for added security. Always apply for the latest security patches to database software to address vulnerabilities. Configure Windows Firewall to restrict access to specific database ports like port 1433 for SQL Server, and enable auditing to monitor activities for suspicious behavior. And here is how to harden databases on Linux. On Linux, similar hardening technique apply on first SSL/TLS database services like MySQL or PostgreSQL to encrypt communication. Implement role-based access controls within the database to limit user privilege. Use iptables or UFW to restrict access to database ports and specific IP addresses. Employ security frameworks like SC Linux or AppArmor to add an additional layer of access control. As always, keep both the database software and OS package up to date to prevent exploitation of known vulnerabilities. These are the best practices for database hardening. Additional hardening measures include disabling unused features and services to minimize the attack surface. Regular backups are crucial, ensuring data can be restored in case of loss or corruption. Database activity monitoring tools help detect suspicious activity, and and adhering to the principle of least privilege restricts users' access to only what is necessary for their role. That's encryption. Encryption is a key aspect of database security. For data at rest, employ methods like transparent data encryption (TDE) to secure stored information. For data in transit, using SSL/TLS to encrypt communication between clients and servers, preventing data interception. Strong key management practices are vital, ensuring that encryption keys are securely stored and managed. These are the database security tools. For securing databases, Windows users can leverage tools like SQL Server Management Studio to configure settings and enable auditing. Linux users have MySQL Workbench, PZadmin, and MongoDB Compass for configurations and monitoring. Third-party solutions such as Oracle DataSafe and IBM Guardian offer additional layers of security and monitoring capabilities for various database environments. These are the challenges and considerations. While these security measures are essential, they can introduce challenges Challenges. Encryption and activity monitoring may impact database performance, particularly for large datasets. Implementing SSLs like TLS and access control can be complex and requires careful planning, especially when integrating with existing infrastructure. Additionally, compliance with standards like GDPR or HIPAA HIPAA may impose specific requirements that need to be factored into security strategies. In conclusion, databases are the backbone of many applications, and securing them is crucial to protect sensitive information. Hardening databases on both Windows and Linux involves implementing encryption, access controls, regular monitoring, and consistent updates. By adopting these practices, you significantly reduce the risk of unauthorized access and data breaches. Always review your security posture periodically to adapt to evolving threats. Thank you.